Hello guys, today we're going through all AQA transitional metal reactions you need to remember. So this did take me a long time because I have to go through every single paper and basically go through what equations they used, what colors they used, and I basically made a whole thing on it. It took me so long to write, but yeah, let's get started. So we want to do the reactions with NaOH first. So these ones normally come up. So you basically want to remember all these colors and all these equations, and I'll show you a quick way to do it. So the ones for Fe and Cu, they're actually quite similar because they just they use the same format, but the only thing that is different is the Fe and Cu part. They just change throughout the equations. And what happens is that this OH over here, it takes the place of two H2Os, and so then two H2Os is displaced as well. And you need to remember the colors. So these ones, they're solutions because it's a 2 plus, right? It's a 2 plus, meaning that it's not a precipitate. What a precipitate is pretend you have like water and you have copper 2 plus, for example. Can't draw it properly on here, but if you have copper 2 plus, that's going to be in a solution, and if you have copper, it's going to act as a solid because the 2 plus and the water is polar, meaning they will interact with each other, so it won't be a precipitate. But if you have copper, that means it will be a precipitate. Then you also have, so these two are fine, and these form a green and blue precipitate because they have no charge on it. Because it doesn't have the molecule doesn't have any charge. That means a precipitate is formed as well. And then you have FeH2O6. So these two are the same as well. So instead of getting four H2Os, because you've got three OH minuses, and realize that 3 is the same because of the charge over here. So you can do FeH2O6 with 3 OH minus, and you'll form FeH2O3OH3. So the 3 OH has taken the place of the 3 H2Os in here, and you also formed 3H2O. So these two are the same for aluminium. And this color here, yellow, you can either say it's orange or yellow or violet, but I think yellow is mostly used in the AQA specification. And then aluminium is a colorless solution and it turns a white precipitate, and this one turns a brown precipitate. An important one is number 5. So this product that we form over here can actually re-dissolve in NaOH. So you can dissolve in excess NaOH, and it will form us this colorless solution again because it's a negative charge. So it's going to form a solution, and that goes back to a colorless solution. And you also form H2O because you started off with 3H2O. You add a OH4 in here, right? That means that because aluminium has to keep its octahedral shape wherever it is, that means that H2O is also produced at the end. So this is all the ones you need to know for NaOH. Let's go to the next one with NH3. So it's quite similar for most of them. So for the first one, there's actually more equations though, but for the first one, you've got FeH2O6 plus 2NH3. And what happens is that the NH3, it like uses a mechanism, attacks the H and the OH, and then it will H2O, sorry, and then it will cancel off and form an OH2. So you get the same product as the ones before, and you also form 2NH4 plus, right? You can think about it because over here I lost 2 hydrogens, and so I put it in here and I get 2NH4 plus, and it also forms a green precipitate because it's the same one. For this one, we've actually got 3 copper equations. I think that's as many as you'll get for copper. Because you've got copper H2O6, you first add it with normal NH3 and it will be the same reaction as the Fe. You'll form H2O4 OH2 and then 2NH4 plus. Then what you do is that you get this product and you react it 4NH3 again, and it'll form Cu NH3 4 H2O2, and it'll be it's a 2 plus, so it'll be a solution again. So it won't be a precipitate because it's charged, and then it'll form this 2OH minus and 2H2O. Or that's one of the steps you can have, or you can just directly have the CuH2O6 and add it to 4NH3. You form the same product but also 2H2O. And the colors are here are different. So you start with a blue solution, of course, and then blue precipitate. Afterwards, you got this blue precipitate, which goes to a deep blue solution, right? Which is this. Or you can start from a blue solution, which is this, and then you can go all the way to a deep blue solution using the fourth step. And then the other two are pretty much the same. You add 3NH3, you get OH3, HOA3, and then 3NH4 plus, and the colors are the same as well. Then you've got reactions with CO3 2 minus. So they're pretty easy to remember. You just do, for the first two, you do one of them. So you add one CO3 2 minus and you form FeCO3 and 6H2O. And you've got CuCO3 and you form and plus 6H2O as well. And they form the natural colors as well, the precipitates, like any other reaction. These ones are a bit more difficult to remember, but you probably want to remember the numbers 2, 3, 2, 3, 3, and just remember the equations and then duplicate them. So if you have 3CO3 2 minus, you still form this brown precipitate, but because you got the CO2 produced, that's why it gives fizzing, or you get effervescence as well, right? The same thing. But remember the numbers and remember the equations, and that'll be fine. Now you can there's reaction with Cl minus. So these ones are pretty standard as well. You can just react all of them with 4Cl minus. Nothing too special about this. And you can actually just derive the charges. Think about it, Fe has a charge of 2 plus and this is minus 4, so I'll give 2 minus. Same for this. For these you have 3 plus minus 4, which gives you minus 1. And they all form 6H2O anyway. The colors are pretty similar. You get yellow solution, yellow solution. Because this one started at yellow, it will still remain as yellow. But this one's a bit different, the fourth equation. It forms actually a colorless solution as well. So that's all the reaction with Cl minus. And then lastly this is a pretty easy one. You can just react it with its H plus again. So if it says like H2SO4 anything, you can just go back to its original solution, and the colors you obviously know this is the standard, right? So this is a green solution, green precipitate, blue solution, blue, sorry, no, I mean, what am I doing? Blue, green precipitate, green solution, blue precipitate, blue solution, yellow precipitate, yellow solution, colorless, white precipitate, color solution. And then you just remember that when you have 2H plus to this, you get back to this. If you have 3H plus, you get back to this. Yeah, and that's all the equations you need to know.